formula is the one that it's the, if all else fails, quadratic formula, here we come. Okay? So, with that in mind, you know, some of these might be able to be solved other ways, but we're going to practice with quadratic formula. So, quadratic formula, you would have learned this back in Algebra 1. Right here, folks. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now, you remember your blue papers. Is this on the blue paper? It is. I'm being nice. You don't even have to memorize it. Now, would it be beneficial to memorize it? It would be. Okay? I can't guarantee, you know, it will always be given to you, but, you know, it's beneficial. Now, this is based on where ax squared plus bx plus c equals 0. So that's where our ABCs are going to come from. And then the a cannot equal 0. And that's only because if a equals 0, then it's no longer a quadratic. It's no longer x squared. Okay? So, with that in mind, shall we jump right in and look at a? Okay? So, first things first. Always take a pause and make sure your equation equals to 0. On a, does my equation equal to 0? It does. And if you want it to first, you could try, because there's an a value, and do product of AC, or what more of you do is slip and slide. But I'm going to tell you right now that a lot of them, they wouldn't work for that today. Okay? On occasion they will, but most of them aren't going to work. Okay? So you'd be stuck trying to find a product in some that don't work. So, let's start with our ABCs. What's A? 3, because it's the number in front of x squared. What's B? Negative 4, because it's a number in front of x. And what's C? And C is negative 9. Okay? From here, folks, plug them into your formula. Okay? So, it's always going to start off x equals, and my first suggestion, write it all out. Okay? Negative b. So, what are we doing for negative b? Yeah, it's going to become positive 4 plus or minus the square root of b squared. So, I'm going to write it as negative 4 in parentheses squared minus 4 times a, which is 3, times c, which is negative 9, all over 2a. So 2 times 2. Okay? As you get better about this, you maybe decide that you don't feel the need to, you know, to maybe do some simplifying as you go. But my encouragement is always to do what you can here. Okay, let's start the cleanup process. Out front, that 4 is just going to stay 4. Plus or minus negative 4 squared is 16. Now, if you are a calculator person and you put everything in the calculator, your call, your choice. I'm not saying you can't. However, beware. There is a difference on your calculator if you put this in versus if you put this in. Okay, they're going to give you different answers. And so beware, we're wanting to do the one that is negative 4 squared. And what is negative 4 squared? Positive 16. Okay, so realize, I guess my point is, b squared is always going to be a positive. Okay, that will always be a positive value right there. Now, this next piece. I see negative 4 times 3 times negative 9. Well, what is 4 times 3 times 9? 108. Okay. And then, since there was a negative times a negative, what's a negative times a negative going to be? Positive. So it's going to be 16 plus 108 all over 6. Okay. If you went ahead and finished your adding, that's great. Okay. Take as many or as few steps as you want. So I'm going to finish cleaning this up. 4 plus or minus the square root of, what's 16 plus 108? 124, did you say? All over 6. Okay. Now, the question becomes, are we done or not? Okay. Now, let's talk about what we can't do right now. Why am I going to say we can't reduce 4 and 6? That may be breaking news to some of you, because some of you are getting ready to reduce 4 and 6, I'm sure.
Because 6 is bigger than 4.
No, 6 can still reduce as a fraction, but if this 6 is going to reduce with 4, this 6 also has to reduce with this radical. And a 6 outside the radical, you don't get to reduce with inside the radical. It would have to be something outside of the radical, and there's nothing outside of the radical. So the idea is, if this is going to divide, we have to have a number that divides into 4, 6, and whatever's outside the radical, which at this point is just an invisible 1. Now, what I am going to tell you to watch out for, square roots. First of all, is 124 a perfect square?
No.
No. If you punch in 124 into your calculator, you get a lovely little decimal. However, you need to be checking, are there any perfect squares in 124? I think we talked about this a little bit in the first half of the chapter. 124, any perfect squares in 124? And this is where a calculator by your side is helpful, yes?
11 and 1.
No. Okay, think perfect squares. What are perfect squares here? Give me some numbers you can take the square root of.
9.
Okay, we can take the square root of 9. Does 124 divide by 9? No, you get a decimal on the calculator, right? Have the calculators beside you. Try them. Okay. What are other perfect squares? 2 is not a perfect square.
100.
100. Does 124 divide by 100?
No.
No.
4.
Is 4 a perfect square?
Yeah.
Because the square root of 4 is 2. Now, importantly, does 124 divide by 4?
Yeah.
It does, yes? You do on your calculator 124 divided by 4, and it's, what do I get?
31.
So, can you agree that the square root of 124 is the same as the square root of 4 times the square root of 31? Okay, except, what do we know about the square root of 4?
It's 2.
It's 2. And when you take that square root of 4 and get 2, it's outside the radical. What about the square root of 31?
Where did it stay? 31?
It's going to stay the square root of 31. Okay, so all of that to say that we need to keep going. The square root of 124 is going to change a little bit. So now I'm going to rewrite this as 4 plus or minus 2 times the square root of 31 all over 6. We're almost there, but I'm going to go one more step. What do you notice about all three terms here? They're a multiple of 2. Can you see that all three terms can divide by 2? 4 divides by 2, yes. 2 square root of 31, 2 divides by 2. And 6 divides by 2. So what can we do to reduce this and give our final answer? Divide everybody by 2. If you divide everybody by 2, 4 divided by 2 is 2. Plus or minus 2 square root of 31 divided by 2.
Where did it be?
31.
31.
Square root of 31, good. And 6 divided by 2. 3. final answer I'm looking for there is 2 plus or minus the square root of 31 all over 3. Again, we can only do that because all of them are divisible by 2. Now, before I move on to the next one, I'm trying to remember if in homework you have to pick something about the types of answers or not. But nothing else, we've got to talk some vocabulary here. How many solutions are here? How many answers are there to this problem?
What do you mean by there's one answer?
How many answers are there? So my quote answer is 2 plus or minus the square root of 31 all divided by 3. That plus or minus indicates how many answers are showing. There's 2. There's one that is 2 plus the square root of 31 all divided by 3. And then there's one that is 2 minus the square root of 31. Okay? Are these real or non-real answers? In other words, real or imaginary? This is real. I didn't get any I's, did I? So, okay, I'm trying to lead you here. There's 2 real answers. Agree? Now, do they do... And the other part, I don't know. We haven't talked this year, I don't think. Rational versus irrational. Rational is something where the total number can just be expressed as a fraction, like number over a number. Irrational involves square roots that we can't do. What do I have here with the square root of 31? Irrational. Okay, when you have square roots that don't simplify, or that you can't do anything with, that's irrational. So, what I've written in my notes is just kind of a reminder is that here we have 2 real irrational solutions.
We gotta put that too.
I would suggest you put it so if something about it comes up in homework, you know what we're talking about. Okay. It's not necessarily something I'm going to require, but it's something that may come up in Savas. And again, it's vocabulary related. I need you to be able to acknowledge, oh, yeah, I understand there's 2 solutions because there's plus or minus. They're real because I didn't get any imaginary numbers. Irrational because I have that square root that turns into a decimal. Okay? Questions there? Okay, let's try B then. X squared minus 9x equals negative 27. What's first? Yeah. I would say what are my ABCs, but I don't want ABCs until this equation is equal to 0. So how do I make this equation equal to 0? Yeah, it's a negative 27, so let's add 27. So now my equation is rewritten as x squared minus 9x plus 27 equals 0. Bless you. Okay. I'm going to write down my ABCs. You don't feel like you have to. What is A?
1.
Invisible number in front of x squared is a 1. What is B? Negative 9, number in front of x. And what is C? Positive 27. Because it's a number added at the end. Okay? Okay, start setting up your quadratic formula for me. Hello. I am. Okay. Okay, it'll probably be the end of the period. Okay, bye. Okay. Did you start setting it up at least?
Yeah.
Practice with the setup. X equals negative b. What'd you put in for negative b? Negative 9, so 9. Plus or minus the square root of b squared. So I'm always going to write that with its negative in parentheses. So negative 9 squared minus 4 times a, which is 1, times c, which is 27, all over 2a, so 2 times 1. Don't forget that denominator, okay? That denominator is important. Don't forget it. And here's what I'll tell you. If you forget it, you tend to forget to come back and get it all together. Okay. So, do some cleanup. 9 plus or minus. What's going on under that radical? Negative 9 squared?
81.
81. It's a positive 81. What about the minus 4 times 1 times 27?
It's like negative 1, like 110 or something like that.
What'd you say, Danielle? Okay. My brain was kind of thinking that, but I needed to confirm since I wasn't doing the math or looking. Okay, so 4 times 27 is 108. Close is good, but not good enough for this. Okay? And there's just a minus sign. We're going to carry down that minus sign. If you haven't already, clean it up, yes. Are we seeing where we might be using calculators more in this lesson?
Nah.
Don't make careless mistakes then. 81 minus 108. Say I got negative something. All over 2. So 9 plus or minus the square root of negative 27 all over 2. Okay. What do we need to deal with here? Square root of negative 27?
We're going to have to use like a 9i or something.
Do we need to talk i's here? Yeah, there's a negative here, isn't there? So first of all, I'm going to split this up with a negative 1 that we're going to peel off. Now, 27. Is 27 a perfect square?
No.
No, it gives me a decimal. Are there perfect squares in 27?
No.
And here's my hint.
Let's see, it's like 3 and 9.
So 9 times 3 is 27, yes? And why did we pick 9? Well, 9 times 3 is the only way to get 27, but also 9 is a perfect square. So square root of negative 1 is going to be a what? I. Square root of 9 is going to be a 3. Square root of 3 is going to be square root of 3. So when you put this all together, you end up with 3i square root of 3. Okay, so let's replace over here. We still have 9 plus or minus 3i square root of 3 all over 2. Final step. Is there anything that divides into all 3 pieces? It'd have to divide into 9, the 3 right here, and the 2. So that 2 thrown in there does not work, does it? So guess what? Answer done?
You gotta do like the...
We're going to talk about what our types of answers are here, okay? Part of understanding here. How many answers are there?
3. 2.
2. There's a plus or a minus. Because on top, you're going to do 9 plus the number divided by 2. That's one answer. Then you're going to do 9 minus the number divided by 2. That's your second answer. So there's 2 answers. Real or non-real?
Non-real.
Non-real. And so it doesn't talk about rational versus irrational in this one. Mine is listed as 2, non-real. And then if you remember, numbers that are in that form, a plus bi, are complex solutions. So I have this written as 2 non-real complex solutions. two non-real complex solutions. So the non-real and the complex are kind of overlapping. Okay, but yeah, when we talk complex, remember complex is of the form A plus BI. Okay. No, yeah, it's all about the vocabulary in that case. Got it? I feel like I'm moving really slow. I don't know if that's good or bad. Okay. Ready to do the next one?
Yeah.
Okay. 2x squared minus 11x plus 12 equals 0. What's first?
Write out A, B, or C.
Okay. If you choose to, write out your ABCs. I can do that because my equation already equals 0. Try and stay a step ahead of me, guys. A is 2, B is negative 11, C is 12. I'm never going to say you have to write out your ABCs. It's a choice. But if you come to me for help and you're getting confused on them, guess what I'm going to have you do? Okay. Formula's at the top of your page. What are we starting with? 11. It's negative B plus or minus. Now what? Negative 11 squared, so B squared. Then
negative 4, 2, and 12.
Okay. Minus 4AC, so minus 4 times 2 times 12, all over 2 times 2, 2A. Okay. I always go back to that radical and clean it up. 11 plus or minus
121.
negative 11 squared is positive 121. Minus 4 times 2 times 12 is going to be
96.
minus 96 all over 4. Okay, continue. 11 plus or minus 121 minus 96 is 25, isn't it?
Yeah.
Okay, so we have 11 plus or minus the square root of 25 all over 4. What's next?
The square root thingy.
Square root of 25 is
5.
5. Should I keep going then?
Yeah.
Yeah. I'm going to count you wrong here. Savas is going to count you wrong. Keep going. So now I'm at 11 plus or minus 5 all divided by 4. And I'm going to say, keep going. The last two, we kind of stopped here, didn't we? Unless we could reduce something. But the last two, I had square roots involved, so we couldn't go any farther. Can I go farther on top?
Yeah.
Yeah, we can go farther here. So think about this as two pieces. There's a 11 plus 5 divided by 4, and there's a 11 minus 5 divided by 4. When that square root simplifies, keep going. So 11 plus 5 is 16, divided by 4 is 4. 11 minus 5 is 6. 6 divided by 4, 1.5. I'm going to keep it improper, though, and say
3 halves.
3 halves. There's a chance Savas will let you say 1.5. Okay. They'll never really let you go 1.5. Improper fractions, while we talk about them and use them in our language sometimes, they never want them as final answers. Okay, so we have answers of 4 and 3/2. Okay? Always go as far as you can there. Okay. How many solutions do I have?
1, 2.
2. This is the most obvious one yet, right?
Yeah.
Real or non-real?
Real.
Real. Rational or irrational?
Rational.
We just made fractions of these, didn't we? There's no square roots left. So we have 2 real rational solutions. Okay. D. X squared plus 9 equals negative 6x.
So we just added over.
Okay, well, you can't do anything until we make sure it equals 0. So we are going to add the 6x over. Okay, when I add it over, what does this read?
X squared plus 6x plus 9 equals 0.
Okay, notice the order. X squared plus 6x plus 9 equals 0, keeping x squared x constant, right? Okay. Write down your ABCs if you want them. A is
1,
visible 1, B is
6,
6, and C is
9.
9. Okay. Fill it in. Negative B plus or minus B squared minus 4 times A times C all over 2A. So if you're matching with me, it's negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 9 all over 2 times 1. Okay, continuing. Negative 6 plus or minus, what's going on under our radical?
36
6 squared is 36.
minus 36.
Minus 4 times 1 times 9, which is 36. All over
2.
2. What is 36 minus 36?
0.
So we have x equals negative 6 plus or minus. Now, officially it's the square root of 0, yes?
Yeah.
What is the square root of 0?
0.
0. So realize, while I say square root of 0 there, that's really just a 0. So it's negative 6 plus or minus 0 all over 2. What's negative 6 plus 0?
Negative
Negative 6. What's negative 6 minus 0?
Negative 6.
So what is this just?
X negative 6 divided by 2.
Negative 6 divided by 2. Plus or minus 0 means nothing. What is negative 6 divided by 2?
Negative 3.
Negative 3. Now, we had an oddity happen here, didn't we? All along today, we've had 2 solutions. What do we have now?
1.
Just 1. Okay? That happens sometimes. Okay? What it is it's a repeated solution. So if this one would have actually, these last 2 would have actually factored had we gone that way. Okay? But we're looking at different options of how quadratic formula works. This one, if we factored it, it would have factored into 2 identical parentheses. Okay? So there's 1 solution, real or non-real?
Real.
This is a real number, so 1 real, and what I'm going to call it is a repeated solution, because there'd actually be 2 of it if you factor it. Okay? So 1 real repeated solution.
We don't don't put if it's rational or irrational in it?
They didn't, but what would it be?
Irrational? Maybe. I don't know. I don't know the difference for real.
Well, we need to know the difference. What's irrational mean? We've only had, well, the first two were irrational, I guess. Well, we only put it in one of them, though. Irrational basically means there is a square root that you can't simplify.
Oh.
Okay, so when we go back to like this one here where we said irrational, it was because of the square root of 31. That's what made it irrational. Okay, technically this one here, square root of 3, that would be irrational. Okay. Okay. Let's get in this next problem. Let's talk about Dion. Okay. Quadratic problems, folks. Great word problem problems. Okay. You see lots of them. Now, good news. We're going to be doing the same thing we just did. It's just a matter of figuring out what they want here. Dion throws a ball into the air. The height h of the ball in meters at time t seconds is modeled by the function h of t equals -5 t squared plus t plus 4. When will the ball hit the ground? What do we know about the ball hitting the ground?
It can be at 0.
What's going to be at 0?
Like the height h, right?
Yeah, the height. The h of t is going to equal 0. So what are we going to do here? We're going to put in 0. So this equation becomes -5t squared plus t plus 4 equals 0. Okay. And then what do we have? We have a quadratic equal to 0. Can we solve? Yeah. Okay. This one, again, I'm going to take this quadratic formula. Technically, this one would factor if you really wanted to do slip and slide.
No.
Okay. Okay, did you write down your ABCs? Or are you over it?
I wrote it down.
A is -5, B is,
1,
and C is
4.
4. Okay. Now, instead of saying x equals, I'm going to mix it up on you and I'm going to say t equals. Why did I do that? Because we're not solving for x here, we're solving for t. Now, I'm not a stickler on that, to be honest, but, you know, proper form is what I should be doing here. Okay, -b plus or minus the square root b squared minus 4 times a times c all over 2a. So if you filled it in, -1 plus or minus the square root of 1 squared minus 4 times -5 times 4 all over 2 times -5. Okay, well, -1 plus or minus, what's going on under that square root?
It's going to stay 1.
1 squared is 1, minus 4 times -5 times 4.
It's going to be 80.
80. Adding or subtracting 80?
Adding.
Adding 80, because it's a negative times a negative. All over -10. So now -1 plus or minus the square root of 81 all over -10. Now -1 plus or minus what? 9 all over -10. Should I stop here?
You're going to do like the 2 problems.
Yeah. There's no square root in here. There's no imaginary numbers. Keep going. Do the math. So I'm going to do -1 plus 9 divided by -10, and I'm going to do -1 minus 9 divided by -10. So let's see. Negative 1 plus 9 is 8 divided by negative 10. If I reduce 8/10, my brain says negative 4/5. Or you could be a decimal, negative 8/10. And then negative 1 minus 9. Negative 10 divided by negative 10. 1. So we got answers of negative 4/5 and 1. What was the question here?
Ground.
When will the ball hit the ground?
Oh, 1.
Will it hit the ground at negative 4/5 second? No. That's what I would call an extraneous answer. Okay. Yeah, we got it. It worked in the problem, but it doesn't make sense in our answer. Okay. So you're just going to have the answer of 1. So it's going to at t equals 1 seconds is when it's going to hit the ground. Okay. I'm going to go with that's a good stopping point for today. Okay. If you feel motivated, you have 2.5 done and you want to get started working on 2.6, start working on the ones that say solve using the quadratic formula. Okay? Because you know what you're doing. On the back of the page, we're going to talk about the discriminant and how it can help us find how many and what type of solutions there are. So, if it's talking about how many and what type of solutions, we'll talk about that tomorrow. But you could do anything that says solve using quadratic formula. Okay?